Right. Good evening, Budehari. Good evening, all. So this is speed revision 9. So I am going to begin the session from here. Right. So first of all, you should do speed revision. Sorry, don't write the questions. Right. Questions right. Don't write the questions. Right. Just provide the answers. Then after the class, I will send this PDF to the group so that you can take a printout and paste it under the speed revision 9. Right? So just provide the answers. No need to write the questions. Right? There are 6 questions from your past lessons. Right? This is from number patterns, and the current lesson. Right? Binary numbers and fractions. Then after that, we are going to do some from fractions as well. I will start discussing this one and right. Yes. Right. Yes, okay. So the speed revision 9. Right? Because I want to save the time, right? I want to save the time so that I have done this one now. Right? Time right? So this is speed revision 9. Right. So the first question is, what is the general term of multiples of 3? What I say, multiples of 3, you know, right? You know, multiples of 3, right? So first question, part A. Multiples of 3, the general term will be 3n, right? Multiples of 3, 3n, right? Part B, what is the general term of triangular number pattern, right? So normally we are representing the general term by using Tn, right? Tn, sorry, I forgot that. Tn equals 3 times n, right? Then triangular number pattern, n times n plus 1 divide by 2, right? Divide by 2. Then part C, odd number pattern, general term is Tn equals general term n term 2n minus 1, right? 2n minus 1. This is for odd number pattern, right? I will write it. General term of odd number pattern. Right? This is general term of triangular number pattern. Right? Triangular number pattern. So this is multiples of 3, right? So I'm not going to write that. Right? Okay, nice. So now second one. Find the general term of below number pattern and then find the 10th term. So you have a number pattern something like this 4, 7, 10, 30. So this kind of a question can be there in your exam. Right? Right? Sorry, message. Right. I will start it from the beginning. So, here you have been asked the multiples of 3 times 8. Right? Then in the second question, they are asking from you, what is the general term of triangular number pattern? So it is Tn. Tn represents the general term, right? N times n plus 1, right? N times n plus 1 divided by 2 is the general term of triangular number pattern, right? Then odd number pattern, right? Odd number pattern, general term is 2n minus 1, right? 2n minus 1, right? So what I will do the second question again so that you can understand, right? Right. So first of all, I have written down my number pattern that they have given 4, 7, 10, 30. You need to find the general term of this. First step that you need to do is to find the common difference, or CD or simple D, right? Simple D. No need to write this common difference at all, right? Make a name, but if you want, you can write, or you can just write D, right? So here you can choose any term except first term. So I will choose 30, right? Then minus previous term. Previous term is 10, right? Previous term is 10. So get the subtraction. The subtraction is 3. Okay, bro. So now, if you get the subtraction 3, right? That means the common difference. When it comes here, you need to remember. You need to use, right? What? You need to use multiples of 3. Multiples of 3. That is 3n, right? The general term is 3n. Keep this in your mind, right? Make a with yards, right? Then I will write multiples of 3 here. 3 here, right? So 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 12, right? Then I will write my number pattern that they have given under this one. 4, 7, 10, 13, comma, blah, blah, blah. Now, how you are going to obtain this new number pattern, right? By using our multiples of 3. So, just you have to add 1, right? To each and every term, you have to add 1. 6 plus 1, 7, right? 9 plus 1, 10. 12 plus 1, 30. So, if you add, right, this constant, right, constant number 1 to your multiples of 3, you will get the general term, right? So if you connect these two terms, 3n plus 1, right, then you will be able to get the general term of our given number pattern. That is this. Tn equals 3n plus 1, right? 3n plus 1, right? So if you want to find the 10th term, just substitute n equals 10, right? So T10 will be, right? Here you have n, instead of n, you have to substitute 10. So 3 times 10 plus 1, 30, 31, right? So third one is convert 1, 1, 1, 1 base 2 into a decimal number. But easily, right? So I hope you can remember what I have told you earlier, right? So before going into that part, right? You would better write 2 to the power 0 equals 1, 2 to the power 1 equals 2, 2 to the power 2 equals 2 times 2, 4, 2 to the power 3 equals 2 times 4, 8. Right? If you want, you can write furthermore, right? Right. So this one, I will write it with a somewhat space between one each and every one, right? So under this one, I will place 2 to the power 0, right? Then I have 2 to the power 1, then I have 2 to the power 2, then I have 2 to the power 3. Right. Now I can write this one, right? 1 times this, right? Each and every number has been multiplied like this, and I am going to add them later, right? 1 times 2 to the power 3 plus 1 times 2 to the power 2, right? Plus 1 times 2 to the power 1, right? 1 times 2 to the power 0, right? Right. So equal mark 1 times 2 to the power 3, 2 to the power 3, 8, right? Plus 1 times 2 to the power 2, 4. That means 1 times 4, right? Actually, no need to write 1 times because 1 times something is same number, right? So I will avoid that, right? Omega I right? 1 times 8, 8. 1 times 4, 4. 1 times 2 to the power 1, 2 to the power 1, 2. 1 times 2 is 2, right? 1 times 2 to the power 0. 2 to the power 0 is 1, right? So 1 times 1 is 1, right? So add them together, you will get the base 10 number. 8 plus 4, 12 plus 12 plus 2, 14, 14, 15, 15 base 10. Right? Okay. Then fifth question, sorry, fourth one, right? Convert 127 decimal number into an binary number, right? 127. If you want to convert this into a binary number, base 2 number, right? You have to divide, right, this number until you get 1 or 0. Last week, right? Until you get 1 or 0 at the end. Right? Doesn't matter. Right? So I will do both of them. Right? 2 times, here you have 12. 2 times 6, 12. 2 times 3, 6. So the remainder is 1. Again, I will divide it by 2. 2 times 3, 6. 2 times 1, 2. Get the subtraction. Remainder is 1. Now here you have 31. 2 times 50, 30. So the remainder is 1. Then again 2 times 7, 14. So the remainder is 1. Again 2 times 3, 6. Remainder is 1. Right? Again you have to divide 2 times 1. The remainder is 1. Alright? So if you are doing this one, this method is also correct. Right? Doesn't matter. In a school, sometimes they might get something like this. Again, you have to divide it by 2. There is number 1, right? You have to divide it by 2, right? So, how many 2s are there for number 1? 0. So, the remainder is 1. If you write it from here, right? Here to here, doesn't matter. Right? 1, 1, 1, 1, 1, 1. In OLs, right? OLs, if you write it from here to here, same answer you will get. So it doesn't matter. Right? Right. So your answer will be 1, 1, 1, right? 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. The base is 2. So you are converting 127. Base 10. If you want, you can write. Correct? Right. Then we have to add 2 numbers. That one is very easy, right? You have to add. Then you have to subtract, right? So fifth one, 1, 1, 0, 1 base 2, right? Then you have to add 1, 1, 1, 1 base 2. So I told you when you are adding, right, you have to represent number 2 and number 3 most of the times, right? Number 2 can be represented by using 1, 0 base 2. Number 3 can be represented by in binary numbers 1, 1 base 2. Alright. So you need to remember these two very well if you are adding binary numbers. Alright. Right. 1 plus 1, 2. 2 can be represented 1, 0. So put 0 here, take 1 there. 1 plus 1 again 2. 2 means 1, 0. Put 0 here, take 1 there. Right? 1 plus 1 plus 1, 3. 3, 1, 1. So put 1 here, take the other one here. 1 plus 1 plus 1, 3. 1, 1. Right? So your answer will be this one. Right. Then you have to subtract. Then you have to subtract. So this is the 6th question. 1, 0, 0, 1, 0, 0. Subtract 0, 1, 0, 1. Base 2. Today, when you are writing these things, as I told you in last week, right? Please keep it clear, very clear, right? පට්ට clear එක ලියන්න සහ please align them, right? Please align them, right? Otherwise you will get messed with that, right? 0 minus 0, 0, base 2, 0 minus 1, you can't do, take 1 from here, it becomes 2, 2 minus 1, 1. Now here you have, previously you had 1, but now here you have 0 because you have taken 2 there, right? So 0 minus 0, 0, right? So here you have 0, you can't do anything, right? Take 1 from here. To take that 1 to here, it becomes 2, 2 minus 1, 1. But you are jumping it here, so now here you have 1, right? Here, then it goes to here, right? So 1 minus, here you have nothing, so keep 1 here. This 1 already has been taken to the right hand side, so this becomes 0. So no need to put 0, your answer will be this. When I make 1, 1, 0, 1, 0, correct? Right? Okay. Up to this place, do you have any questions to clarify? මොනවාරි තියනවද?